Okay, so this video is going to be about transformations. The first transformation I'm going to talk about is going to be rotation. So rotation is to change the orientation of the shape, but without changing its size. So to twist it around. So I'm sure you're familiar with rotating your mobile phone, and then you have all the images on there all reorientate sideways. So rotation is like that. It's basically twist around, except in this case on your phone, usually it will resize and to fit your screen better. But in here, the shape of the size of the shape will be exactly the same. Now we specify a rotation by three things. So firstly, we need to specify an angle, whether it's 90 degrees, 180 degrees, 45 degrees, whatever. We also need to specify a direction, whether it's rotated clockwise or whether it's anti-clockwise. And then we need to specify a center of rotation. So I'm going to explain how that works with the help of my triangle I've got down here. So here I have triangle. Now I can highlight it and I can use my rotate tool here and I can rotate it around. So as you can see, it can rotate around, and as it rotates, I can change the angle here. So let me try and get it straight there like that. So now I've rotated it 90 degrees from where it was. If I rotate it around again, this is clockwise. I've rotated it another 90 degrees around there. I can rotate it around some more. 180 degrees, it's back where it was, upside down. Here, 270 degrees will be there, and then back around here, back to where it started. So that is how a rotation will work. So I would also, if I would go around the other direction, then I would need to specify that I've gone anti-clockwise. So I've done 90 degrees, although the angle there was showing me 270 because it's measuring clockwise. I could say 270 is the clockwise is the same as doing 90 degrees anti-clockwise. So that's fine. Now, when I did my rotation, I've got this little target here, which is the center of rotation. So when I did it, it rotated around that being the center. So if you imagine I'd drawn the shape on a piece of tracing paper, and I'd stuck the pin here, then the paper would rotate around this point. What I can do is I can pick up this center of rotation and move it somewhere else. So say I can move it over here to the origin, and then I can do my rotation again. And you'll see that the shape will still rotate, but it will now look different to how it looked before. So when I do it 90 degrees, it's still the same orientation it would be before, with the main point down and the short side horizontal, but it's ended up in a completely different place because the center of rotation was different. I could also do it around the other way. So using the center of rotation as different will make the result be different. So when you specify a rotation, you need to specify the angle, and you need to specify the direction, and you need to specify a center of rotation. So you specify those three things: the angle, the direction, and the center of rotation. Now, how can we work that out without picking it up and moving it about? So say I have my triangle here like that. What I need to do is to look at the point. So if say I want to rotate it, let's say first of all we're going to use the center of rotation as this point here. So just start it on the corner there. So if I want to rotate it about here, this side here, which is currently vertical, if I rotate it 90 degrees clockwise, this line would end up being horizontal across here. And this horizontal line would end up being vertical down here. So this line here, which is 2, would end up being 2 along here. So that point there, which was 2 vertically, will end up being 2 horizontally. This point here, which to get to that point, I'd have to have gone 2 and then 4 along. So I would go the other way. Instead of going 2 up and then 4 to the right, I would go 2 to the right and then 4 down. Because this would be twisted, this would end up being down. So my next point would be down here. And so my triangle would look like this. Okay, so if I just rotate it around this corner point, it's going to look like that. So I can check that. Let me use my rotation tool. If I move the center of rotation just to the corner here, and then I can pick it up and rotate it around, and I can see that it does drop exactly on where I thought it would be. 90 degrees, it's just there. There. Okay. So that would be like that. If I rub that out, say instead I wanted to rotate it about some other point further over here. So say I want to use this point as the center of rotation. then what I would do is I would see what the relation was to this point to where my center is. So this point here, this point here, to get to that point, I would have to go up 3 and then 3 to the right. So if you imagine there was a line that went to that point there, when I rotated that L shape there, it would go 3 this way and then 3 down here. So to work out my point, I would use that rotated around. So it would go 3 to the right and then 3 down, and this point would end up being over here. Let's do a different color. So that would be 3 and then 3 down. It would be here. All right. I could then work out this point. To get to this point, it would be 1, 2, 3, 4, 5 up and 1, 2, 3 to the right. So when I did it here, it would be 5 to the right, 1, 2, 3, 4, 5, and then 3 down, it would be here. So I can see that this short side here would become this short side here. This point over here was 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5, 6, 7, 8 to the right. So when I go from here, it will be 5 to the right and then 8 down. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7, 8 down here. Okay. I should also know that my triangle's got to be the same proportions as it was before. So this side had a side length of 2. This side had a side length of 4. So 1, 2, 3, 4. So I actually see that I've drawn it in slightly the wrong place there. It should be there. So my new triangle, after I've rotated it 90 degrees clockwise about the center of rotation, which is the blue point, should be there like that. So if I wanted to specify this as my center of rotation, I would just give the coordinates. So this coordinate is 2, 1. So to get from the green one to the purple outline, I would say I've got a rotation 90 degrees clockwise about the point 2, 1. So I need to write down all of those things. So it would be a rotation 90 degrees clockwise, because 90 degrees anti-clockwise or a different angle clockwise would be in a different place. And then I would need to say about 2, 1, specifying the center of rotation here. Now I can check that. I can drag my center of rotation over here. Like so. And then I can rotate it around, and I should see it drops directly on top of where I thought it should be when the angle was 90 degrees. Like that. So that's how rotation works. I can move that back to where it was. Like that. Okay, so let's look at a question and see if we can work out how to do this. So the question says, describe fully the single transformation that takes shape A to shape B. Shape A is here, shape B is here. Now, if we look carefully at the shape, we can see it's trapezium, and the base here is horizontal, whereas here, the base is vertical. It's the same size, though, because this is 4 long and this is also 4 long. So it's the same size, it's just twisted around. So hopefully you can see then that that is a rotation. Now, because this horizontal here has changed to vertical, and then this slopey side here has ended up round here, you can see it's a rotation clockwise 90 degrees. So to get this round to here, I'd need to turn it clockwise, this direction, 90 degrees. Okay, so what we need to do now is to work out the center of rotation. So if you imagine you had a piece of tracing paper and you stick your drawer around this shape, put your pin in it, and you've got to twist it around, center of rotation is going to need to be over here somewhere. So what we're going to do is we're just going to try a point and see what happens. So say I thought it was here. Then if I look at this point here, so I'm going to try with that. So this point here, from the center of rotation, it's 3 up and 2 to the right. So when I twisted that around, the 3 up would become 3 to the right, and the 2 to the right would become 2 down. So this point would end up here, if this was the center of rotation. So there is not quite the right place. So that's not going to work. So let's worry about my center of rotation and try it some other place. So we could try it here. All right, now from here, I can see it's 2 up and 2 to the right. So that would translate to 2 to the right and 2 down. So that would be the point there. That's worse. That's further away. So that didn't work. Let's try here. Okay, this time, it's 2 up and 1 to the right. So it would be 2 to the right and 1 down. That's not too bad, but it's still not quite right. So let's try one more time. Let's try here. This time, 3 up, 1 to the right. That would be 3 to the right, 1 down. That should be correct. Okay, so this point here, 3 up, 1 to the right would be the same as 3 to the right and then 1 down when I rotated it 90 degrees. So that blue point would become that point there. So that would be correct. And then I'd say with center of rotation, and then I need to specify where that point is. So I need to give the coordinates, which the x-coordinate is 4 and the y-coordinate is 3. And that would get me my marks. There's 3 marks there. So there'll be 1 mark for saying rotation, 1 mark for saying clockwise 90 degrees, and then the other mark for saying center of rotation 4, 3. Okay, so to check that my answer is correct, I can draw the outline of the shape here. I can select it, and then take the center of rotation, put it to 4, 3 where I believe it should be. And then I can take my rotation and I can rotate it around, and I can see that it drops directly on top of where it's meant to be right when I get to the angle of 90 degrees. And that's moved around clockwise, so I can see that that's right.